This week's topic is interpreting geologic history through absolute dating. Last week we learned about relative dating, which allows you to put geologic events into a sequence. But is there a way to know exactly how old a rock is? Well, imagine you are outside and you find what looks like an ancient wooden axe handle. How old is it? How could you find out? Well, for starters, you need to know that wood is made up of mostly carbon, hydrogen, oxygen, and nitrogen. Most carbon is in the form of carbon-12, which means that there are 6 protons and 6 neutrons. Sometimes carbon forms an unstable radioactive isotope, which means that there are more neutrons than there are protons. Only 1 in about 1 trillion carbon atoms forms carbon-14. The carbon-14 radioactive isotope is unstable, which means that it will change into a more stable daughter product. That change is often referred to as disintegrating or decaying, and this happens at a steady rate. So in this example, carbon-14 disintegrates at a steady rate into nitrogen-14. The time it takes for 1/2 of the original sample to turn into a stable daughter product is referred to as a half-life. In the example of carbon-14, the half-life is about 5,700 years. So after that time, you'd have half as much carbon-14 as you started with. This information is given to you on page 1 of your Earth Science reference table, and it shows you that carbon-14 will change into nitrogen-14, and the half-life is written in scientific notation, so 5.7 times 10 to the third is equal to 5,700 years. You can see here that after one half-life, there's about 50% carbon-14 and about 50% nitrogen-14. After 2 half-lives, there's only 25% carbon-14, and as you go, you keep reducing by half. So if you were to find in that sample of the wood handle on the axe that there was half carbon-14 and there was half nitrogen-14, you would have determined that it had undergone 1 half-life, and so that axe handle would be about 5,700 years old. Carbon dating can date any once living thing that is less than 50,000 years old. After that time, there's such a small amount of the sample left that the accuracy becomes much less. So for older objects, other radioactive elements can be used to determine their age. On page 1 of your reference table, you can see the other radioactive isotopes are potassium-40, uranium-238, and rubidium-87. And it shows in the disintegration column what they turn into, and then in the half-life column how long it takes for half of that sample to decay. You can see in this, in a newly formed rock, we might have a lot of uranium, and then as time goes on, there's going to be less and less uranium and more lead. This chart shows different radioactive isotopes, the materials that are useful in dating, and the range in which they're accurate. So for example, carbon can be used to date organic materials like shells and limestone, and the range it's accurate in is 100 to 50,000 years. In comparison, potassium can be used to date biotite and whole volcanic rock samples, and its accuracy range is 100,000 to 4.5 billion years.